Today we are talking about exponent rules and how they work. So if I have a number x to the a times x to the b, then my result is going to be x to the a plus b. So whenever you're multiplying, you're going to add the exponents. So if we look at this example, I have x squared or times x cubed. So I'm going to take those and add the exponent. So this becomes x to the 2 plus 3, which is x to the 5th. Alright, same thing if it goes with the numbers. So this becomes 2 to the 5th, because if I add them, well, I can figure out what 2 to the 5th is. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So anytime it's a number, then go ahead and solve the rest of the way. Alright, example 3, I'm going to multiply the numbers out front, but add the exponents. So 3 times 2 is 6, 2 plus 4 is 6. So in that case, I end up with 6x to the 6th. And you should remember most of these because we've been doing them foiling throughout the whole, basically most of the class. Alright, now here this is called power to a power. If I have an exponent raised to another exponent, I'm going to take those and multiply them together. So here you're going to multiply the exponents. So in this case, I'm going to have x to the 2 times 3, which is x to the 6th. Alright, so if we look at this one, that's going to be 2 to the 6th. If I take, since I know 2 to the 5th is 32 from above, if I take that and multiply by 2 again, I'm going to get 64. So 2 to the 6th is 64. So again, if it's a number, go ahead and solve for the actual value. Alright, when we're dividing x to the a divided by x to the b, this is where you take those exponents and you subtract them. Okay, so if I look at x to the 5th divided by x squared, I'm going to have x to the 5 minus 2, which is x cubed. Alright, so if we look at that same example but with numbers, I'm going to go ahead and get 2 to the 3rd power, which is 8. 2 times 2 is 4, times 2 is 8. Alright, x to the 0 is 1. Anything to the 0 power is always 1. And the only exception is 0 to the 0. Alright, so if I look at this, I have x times y to the 0. Well, if you look, the only part that has a 0 on it is the y, so this becomes x times 1, which is x. Alright, example 8, 23,462 to the 0 power is 1. Because again, anything to the 0 power is 1. Alright, x to the negative a becomes the reciprocal of that, and your exponent is now positive. So in this case, I would have reciprocal of x is 1 over x, and then make it positive squared. Okay, in this case, reciprocal of 3 halves, or 2/3 is 3 halves, and now it's a positive exponent. Okay, so then if I square both the 3, I get 9, square the 2, I get 4, so that would be 9/4. Okay, and the other way you could think about this is if I did it in the fraction part, I would have 1 over 2/3 squared, which is the reciprocal part. It's just easier to flip it from the beginning if it's already a fraction. Alright, radical rules. If I have some sort of radical x times that same sort of radical y, then I can take those numbers and multiply them together underneath. So as long as they have the same number out here, then they're able to be multiplied. So in this case, I have 5th root of 2 times 5th root of 3. Since they're both 5th root, then this becomes the 5th root of 6, because 2 times 3 is 6. And then I can't reduce that any, so that would be my answer. Okay. Same thing with 7. If they have the same number, they're the same radical, when you're dividing, you can combine them as x over y. Depending on the situation, that might help your answer in reducing. So if we look at this example, this becomes just the square root of 10 over 5. Well, we know what 10 divided by 5 is. It's 2. So then that becomes square root of 2, and that's your answer. Alright, flip it over. Alright, now if I have rational, which are fraction exponents of x to the AB, this is written as the b root of x to the a power, or I could write it as the b root of, oh, that should be an x, sorry, x to the a power. Those end up being the same thing. So your b ends up in your radical, and your a is the exponent on whatever number was there. So if I took this one, 3 goes in my radical, so it's cubed root of x squared. Okay, example 14. This one becomes, if I go the opposite way, I get 3 to the 2/4, which is 3 to the 1/2. And if I go ahead and write that out, going back to the radical, I get the square root of 3. And since it's a square, I don't have to put that 2 there, but I'm going to go ahead and put it there. So that's just really the square root of 3. Those are the same thing. Alright, if we take a root of another root, then that becomes 1 over, hold on, let's start again, x to the 1 over those two roots being multiplied. Okay, and the reason it's a 1 on top is because that's the exponent on that x. So in this case, there's a 2 here with the y, because it's the 4th root of the square root of y. So this becomes y to the exponent on y is 1. So y to the 1 over 2 times 4, which is y to the 1/8. Alright, let's look at this one. I have the exponent's 5, so I'm going to have 2 to the 5 over 3 times 5, which if we go ahead and reduce that, I have 2 to the 5 over 15, which is 2 to the 1/3, which is, if I change it back to the radical, the cubed root of 2. So depending on what the question's asking will determine how far you need to go. It might say leave it in exponential form or put it in radical form. So this would be your exponential form, this would be your radical form. Alright, let's look at a couple more examples. I have 27, or cubed root of 27 to the 4th. There's more than one way to solve this. Let's solve it using the rational exponents first. So this becomes 27 to the 4/3, which I can rewrite 27 as 3 cubed to the 4/3. And when you have an exponent to an exponent, you raise it. So this is 3/4 times 3, which is 3 to the 4th, because those 3's end up canceling. 3 times 4 is 12, divided by 3 is 4, and that is 81. Or we could leave it as the cube root of 27 to the, oops, that should be 27. 27 to the 4th, and since that can be rewritten as the cube root of 27 to the 4th that way, I know the cube root of 27, that's 3, so from that way I get 3 to the 4th, and 3 to the 4th is 81. So either way we solved it, we got the same answer. Okay, it just depends on how your brain works. Alright, in this case, let's take it and write it in radical form. So I'm going to have negative 32 to the 2/5, which equals negative 32 is 2 to the 5th to the 2/5, which is negative 2 squared, which is negative 4. Okay, because if you look, that 2 is the only thing being squared, so that's where that negative comes from. Alright, your assignment for this is A9, page 394, 2 through 22 even, and 32 through 46 even. So let me know if you have any questions, and good luck.